the first step, when you see function inside of the function inside of the function, you need to figure out which function is outside, which one is inside, because we're working with layers. So outside function sometimes is not visually obvious. Sometimes it is visually obvious that this guy is inside of secant and secant is inside of sine. But in general, the last function you will do, if I ask you to plug in a number, say 0, that's the last step, which will be first function to work with right now, because it's the outside layer. Just like in Russian dolls. So what function is the last one to work with if you know what stuff is inside? You have sine to the 4, secant, polynomial inside of secant, even multiplication by 3. What is the last step we would do if we plug in some 5? What do you think? If I plug 5, let's do this example. How do you know how to start with a chain rule? If I plug x equals to 0, it first goes into this square. Okay, we worked it out, done. Then we have a secant of some number. We worked it out, done. Then we multiply it by 3, done. Then what? I will do sine of that number, right? And then at the very end, whatever the result I get, I will take it to the fourth power. That's how I know that the fourth power is the last step, which we're gonna do first to perform chain rule. It's a chain reaction, nesting of functions. Or sometimes we do onions. The outside layer of the onion is the power to the 4. Does that make sense? Let me erase all of this. So the outside layer of a Russian doll is power to the 4. That's the outside one. I will differentiate stuff to the 4. It is 4 stuff to the 3. And that stuff should stay whatever it is. Then I'm recognizing the next step. What's the Russian doll is inside? What's the next step? Do you remember? I was just mentioning them in order. What's the next function inside? Sine, not secant yet, because we did not differentiate sine. So okay, I will do times derivative of sine of stuff. Stuff is in those parentheses. Derivative of sine is cosine. Now I look more inside. What's the stuff inside of sine?
3 secant.
3 secant of stuff. Okay, now I have to differentiate 3 secant. 3 secant will require you to know derivative of secant, tangent, sine, cosine. Secant likes itself, so it's secant tangent. Derivative of secant times tangent. Of that stuff. Okay, differentiated that. And now I see there's something inside of secant, and I'm differentiating 7 x squared to the 5. And that's the end. Does that make sense? So you have to keep going in order. And every time I say and, that means times. In logic, and means product, or means addition. That's a class of logic if you ever took it, or it just makes sense. How fast all this function is. It is 4 sine cube fast, and derivative of sine fast, and derivative of 3 secant fast, and derivative of 7x squared plus 5 fast. So you have to keep digging inside of it to answer the question completely, how fast the whole thing is. Does it make sense? Because and. If it's not visual for you that 4 is outside, you can always rewrite it. You don't have to. But you can rewrite it to be in huge parentheses and to be outside. So you can see, oh, everything is to the 4. Now it's kind of visual. Power of the 4 is the first derivative I'm taking. Then sine will be my next derivative because it goes right after power to the 4. But sine inside has a function. That function is 3 secant. So I'll take derivative of 3 secant. And the very last step will be the stuff inside of the secant, x squared plus 5. So this is my nesting of functions, color-coded if you want that. So you can even see, or maybe make up the idea that in purple, so parentheses in purple, all of this is some kind of function. Let's call it u. In the book, they call it g of x. Okay, g of x. I like u. Thus, you see it's y equals u to the 4, and you know how to differentiate that. So let's start it. Let me move it like so. Y prime equals I know u to the 4. 4u to the third, right? So u to the 4. This time I will do very slowly. So you can, this is probably the last time I will do it very slowly. So I want to make sure chain rule is that topic that people stuck with usually. So I know u to the 4. 4 goes down, the function to the third. But what is my u? Whatever is in purple. So I need to copy the whole thing. And I will put it sine 3 secant 7x squared plus 5. We're doing chain rule for those who are late. And then, what color is that? Black. To the third. Does that make sense? I guess I could put it in purple to be consistent. 4, bless you. And then parentheses third. So you see, I copied everything, right? Because it's u. So I know that you copied. I only worked with the power rule. So that was a polynomial. Times, it says and. And. So how fast the whole function is. 4 stuff to the cube and chain rule says don't stop. Chain rule says don't stop. And now you look one step inside. We just agreed it's sine. So I'm going to take derivative of sine of stuff. So everything inside of this sine now is, it's in green color. Everything inside of this sine is u. Make sense? So now I see that the sine of u. Can I differentiate sine of u? It's going to be cosine u, right? So I'm going to write this down right now in blue. It's going to be cosine u, but do you know what my u is? My new u. That whole thing inside, 3 secant and stuff like that. I will put it in green. So I copy 3 secant and 7x squared plus 5, like so. Carefully close parentheses. In your homework, you're stuck often because you lose parentheses, just letting you know. Yes?
The way I was taught this before was to put it as y equals u to the 4th, u equals sine v, v equals 3 secant w, w equals 7x
Double W.
squared plus 5. If I just defined all of those and then gave you the answer in terms of u, v, and w, would you accept that?
No, you have to go back to x.
Okay.
So very good question. In some schools they say, can you just define all the functions? It will be u to the 4, and then w is my sine, and then v is a secant. You see, I'm too lazy. I keep defining everything as u, which is actually illegal to do. But some people do u1, u2, and stuff. I don't like that. It's actually okay to redefine the function. You can do whatever you want, but the answer should be in x.
Okay.
So that's the whole point. Because only you know what u is. I like saying that. We're going to do it in calculus 2 a lot with u substitution. So answer should be in the original form. That's not the and. We do times. And we say again, and, right? And means times. Chain rule again. Chain rule says, well, we differentiated sine, but sine had some stuff inside. That stuff inside was 3 secant. Everything in green. So I will do times. That's my way of moving down. Times, and then I take derivative of the function inside. But the function inside is 3 secant. So I'm differentiating 3 secant of u, right? So now I have 3 secant of u. Can you differentiate 3 secant of u? Secant likes itself, so it's going to be 3 secant u, but then tangent u. Do you know that? So that's required. It's today on the quiz. You're required to know this 4 derivatives. No need to know cosecant. No need to know derivative of cosecant and cotangent. I never require those on the tests. And even if they put it on the test, I switch it to tangent and secant. We need to know secant, tangent, because they have connection between each other. Sine and cosine. Good enough. And later it will be arcsine, arccosine though, and arctangent. More 3 are coming later. Do you agree with this derivative though? 3 secant gives you 3 secant tangent. Do you all agree? Let me know if you don't. So I will do in green color 3 secant of u, but what is u? The polynomial. So I will not waste time by copying it later. I will do it right now. 3 secant of that u, right, times tangent of that u. Like so. Are we done? One more step left. Do you know how to know you're not done? There's something you did not differentiate. Probably we want you to differentiate that. But technically speaking, you just know there's more to go. There's polynomial left. Here it is. I'm finally going to go to the very original one, because in the very previous step it's repeated, kind of confusing. This is the last u that was inside of the secant of 7x squared plus 5. So the times, so you see, and how fast the whole function is, this fast times this fast, and this fast, and the last one is derivative of 7x squared plus 5, which is 14x. That's the answer. Can you do that? That was a little bit complicated example, but we require you to know. For homework, this is a good example. For the exam, sometimes we put chain rule twice. But how many times did we have chain rule here? Can you count? First one, second one, third one. There were 3 chain rules, but 4 functions. One outside was power, next inside was sine, next inside was secant, and next inside was polynomial. Isn't cool? And that is the answer. No need to simplify unless it tells you on the test to simplify. Sometimes something simple, I will ask you to simplify something simple. Sounds funny. Questions about this? What do you think? Questions, comments, suggestions, ideas? Then let's do one more implicit differentiation. And I think we can just start having some fun with the quiz. I will just choose some homework problem from yours. Let's do. We did some complicated examples from your homework last time. So let's do another one. This one. Implicit differentiation. So I'm going back to the implicit differentiation topic and going. And let's do this problem. Times x equals 1300. Implicit differentiation, 5x minus y to the 4 plus 4y cubed times x equals 1300. This problem has a classical mistake. People tend to make a classical mistake with this problem. This is the problem we like to put on the test. I'm usually very open about, on the test we want you to perform product rule in the implicit differentiation. So that's usually what we choose. And or chain rule. And this one has both. Implicit differentiation, if you skip last class, that's not good. Don't skip my classes. Implicit differentiation. If you do, you better catch up. Implicit differentiation says, okay, I cannot solve for y. How can I find y prime if there's no y equals blah, 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 just like we had right now, before that example? Then you just drop the bomb of differentiation, differentiate everything. Usually that's actually a more common way of doing it. Usually we don't have a nice written gravity equals blah, blah, blah. Usually there's lots of stuff times gravity minus stuff of stuff divided by gravity. So you kind of have to know how to do it. It's actually a very common strategy. Step 1, differentiate everything you see, keeping in mind that the derivative of x is a simple guy, gives you 1, but derivative of y, that guy is a complicated guy, y prime. So let's figure out how it's going to work. Step 1, I recognize chain rule. This function is raised to the 4. So I'm going to have 4 function to the 3 times derivative of the function inside. Does that make sense? Like this is the easy case. So this is you're supposed to know already by now. Do you understand that one? 4 goes down, copy, because it's your u, right? So 4u to the 3, 5x minus y, times derivative of the function inside. 5x minus y gives you 5, right? Yes, no, yes, no? No. So be careful with this. 5x gives you 5, but minus y gives you minus y prime. Be careful with those little things. If you mess up the first step, everything will be wrong. So just letting you know, it's hard to grade on the exam because all possible mistakes happen. Now, we're done with the first term. So we're going to have product rule now. Look at this. U times V. That's what you're going to have on the quiz today. U times V. Product rule. Product rule says derivative of U, 12y squared.
Ma'am, no. Ma'am, we can't differentiate y.
What? Yeah. Yes, no?
So 4y cube dy by dx.
Times y prime, which is times dy by over dx. Yeah.
But ma'am, we can't differentiate 4y cube because we have to do it dy by dx.
So that's exactly what I'm trying to explain.
That's y prime.
Yeah, that's why we multiply. Very good question here. 4y cube, derivative of that. You first ignore.
Y squared dy by dx.
Yes. You first, what I was saying, you first see y as expression, and you know how to do power rule. 12y squared is your first step based on chain rule. Then times, chain rule says, well, you do times derivative of whatever was inside. What was inside? Y was inside. Derivative of y is dy over dx.
So it's just that we're doing chain rule except our u is equal to y.
Yeah.
So it's 4u cubed u equals y.
Yes. For you, I would say y is u. So just y is your u in this case.
Okay.
So this is how it's nice to explain. This sometimes is click this way. Hear me out. You see y is x at first, and you know it's 12x squared. But then you notice it's y. Derivative of y, we don't know what y is. Y can be sine x plus 3. Y can be square root of x minus 5. Because we don't know what y is, how can I write down derivative of y? I will just keep it unknown as y prime. That's the idea here. We do times derivative of y, but because I don't know what y is, that's the whole point of not having explicit y in front of me. I do times derivative of y. And in the future, when we find it, we're going to plug it in. Or if we ever give it in, we can plug it in. Does that make sense? So that's the confusion here. This is those little things are hard or challenging. So in a silly way, I like to explain it. In a silly way, I like to explain every time you differentiate something with y, y prime pops out because of the chain rule. Because y is a dependent variable. So because x is the last step, 4x cubed will be 12x squared. But because y is not the last step, we have to do times derivative of the function inside. The function inside is y, but I don't know what derivative of y, so it will be times y prime. That's the best way of explaining it. Every time you differentiate something with y, y prime pops out. Bless you. This is u prime. Then it says copy v. Okay, I'm gonna copy v in black, like here. V was x plus copy u, that is 4y cubed, times, you see, I'm not differentiating stuff with y, so there's no y prime this time. Times, differentiate v. What is derivative of x? 1. Let me put big brackets. In this class, brackets and parentheses means the same thing for now. Later, it will not be the case. Brackets usually reserved for matrices and determinants, but it's fine. So, but this is how I like identifying that this, what we did, the brackets. U prime v plus u v prime. These two things here are very hard. So, this is the idea. You agree, disagree? I made several mistakes on purpose, and we slowly try to catch them. Copy, 4 goes down to the third. Derivative function inside, 5x minus 5. 5x gives you 5, but y gives you y prime, so minus y prime. Then product rule. but there's still one mistake left. Product rule. One mistake left. Do you see it?
Do we not differentiate the other side?
Yes. Anyone at the back? Did you see the mistake? Yes?
Are we supposed to differentiate the right side too?
We're supposed to differentiate the right-hand side. It is not 1300, it's 0. So it's a very popular exam on the exam, a mistake on the exam. I would say like 20% of people make this mistake because you're so satisfied that you finished with left-hand side. You forget the derivative of 1300 is 0, and then it messes up the whole answer. But I usually don't take lots of points for this, but still. Do you remember what the second step? Who remembers the second step? The first step is the hardest. Even in calculus 3, we're going to be doing multivariable differentiation. That's going to be also hard. Step 2, from now on,
Take the y, dy by dx.
divide, but before that we should like sort it out. So from now on, the whole goal, all the other steps is to isolate y prime. Because I want to have y prime equals blah, blah, blah. To do that, I need to move around things. So all pieces with y prime are on the left-hand side. Okay, so let me use highlighter or a pencil and identify pieces with y prime. This guy has y prime, so all of this beautiful piece will be on the left-hand side. Let me write it down. So step 2, 12y squared x times y prime. You don't have to reorder it, but it's actually a nice thing to do. X actually usually goes first. Then this guy goes to the right. I don't need it. Then what's happening at the very beginning? Oh, there's y prime here. So I need to keep this piece on the left-hand side. But it's not standing by itself. It has to be first multiplied by the guy over here. So we're going to do partially FOIL, which is actually, and this guy is over here. We're going to do some distribution. It's not even FOIL in this case. So I will write down and you tell me if you agree. Minus, I will put it in different color. Minus, do you know why? Because of this minus. 5x minus y cubed times y prime. That's what I have. And then other pieces are going to the right-hand side. So see what I did here. I'm taking this piece and multiplying by 5 and multiplying by minus y prime. And I'm keeping the y prime on the left-hand side because that's what I want. I'm hunting for pieces that are attached to y prime. Does it make sense? Everything else is garbage. Move it to the right. Garbage means we only need it at the very end. It's not, those are not derivatives. Move them to the right. So the stuff on the right, I have 0 on the right. Let's keep it there. I have this 5x minus y cubed times 5 on the right. That's the one over here. But because I'm moving to the right, guess what happens? Minus, exactly, negative. You subtract. Americans we're taught to do minus on the both sides. And then in other countries, we often are taught we're relocating things. And the moment you cross equal sign, you change the sign. That's how I see it. So it doesn't matter. The way you see it, do it. Just make sure it's correct. Minus.
I think you're missing a
Parentheses. I think it got erased. Thank you. Cubed times 5. Minus 4y cubed. That's also the one guy I did not need. So let me not circle this. So whatever in yellow we keep on the left. Whatever is not in yellow. Maybe like this. Whatever in yellow stayed on the left. Whatever is not in yellow moved to the right. Make sense? You're almost done with the answer. To be honest, step 3 and step 4 can be merged into one step. But I don't want to do it just yet. I will factor out y prime. I will open those huge parentheses and I will write down right-hand side. Or maybe I can show you how to do it faster. Right-hand side. And the answer will be, oh yeah, actually I think you're ready to do that. The answer will be y prime equals right-hand side, which are all guys with no derivative, and by guys I mean factors, only terms that have no derivatives there. Dividing by the parentheses, and parentheses are all, I can actually color code it for you here using some kind of beautiful blue. This was gonna stay in the parentheses when I factor out. Let's see if you can do it right away. That's algebra. Equals, right-hand side is minus 4, 5x minus y cubed times 5 minus 4y cubed. Done. That's right-hand side. RHS is right-hand side. Divided by whatever were in the brackets. And I skipped that step because I can do it right now, but you don't have to if you don't want to. So I'm factoring out y prime from the first term. Factoring out y prime is divide by y prime. So what is 12y squared x y prime over y prime? It is 12y squared x, right? Minus 4 and blah, blah, blah divided by y prime. Minus 4, 5x minus y cubed divided by y prime disappears. That is the answer. This is not an easy material. So if you feel lost and there are too many steps, I definitely agree with that. That's just the case. Surprisingly, it gets better the more, not surprisingly, the more you practice, the better it gets. Yeah? Yeah, that's the one I think is important. This step, right? Let's concentrate, people. Let's concentrate. So distribution here was 4, 5x minus y cubed. I'm multiplying by these guys in the parentheses. So I'm multiplying first by 5, then minus, and then I'm gonna multiply by y prime. 4, 5x minus y cubed times y prime. So that's my distribution. And if you want to see where is it, it's over here in green. So this is what I did here. If I were a student, I would do it with a pencil to save time. I would just quickly do it with a pencil, but you don't have to. You can do it actually, and you can rewrite everything. But you know why I didn't? Because there's lots of stuff to write. Plus, this equals 0, blah, blah, blah. On the exam, you want to be fast. Unfortunately, American exams is like a race, which is not a very good idea. Not everyone are fast. And also, what does it mean to be a good scientist? To be fast? Weird. But I like to teach the way that you can skip steps and have more time to check for mistakes later. So, but did that make sense? Yeah. Thank you for asking. Yes?
In that step you just circled.
Did I mess up?
No. I'm just asking. You can multiply the 4 that's outside the bracket by the 5, right?
Oh, yes. Oh, yeah, good question. 4 and 5, right?
Right, so in the final answer, the numerator could also be
20, right? Yeah, this one. Yeah, good point. Minus 20. Yeah, you can simplify. I kind of, unless you asked for it. Multiple choice on the exam, mostly I want to see that you can do it. So you find it, you locate it, you will get it. What do you think about this? Questions, comments, suggestions? Yes?
I made the horrible mistake of expanding 5y minus x to the whole cube.
Yeah, don't do that. So there's a comment right now, write down the cube stuff, and you know there's a formula for it. Or you do 5x minus y squared times 5x minus... Yeah, don't have to do that. Unless it says simplify, but why would I on the exam ask you to simplify the cube? That's freaking mean.
My brain's almost melted out of my ears.
Your brain just likes challenges. I guess it's a good thing.
No, it was fun, but at the same time, I'm like, what's going on? Yeah.
I see. You see, someone did the cube of difference and then said it was fun. That's your goal. That's whom you want to be, okay? Sorry. Let's do the quiz. It's already posted. Let's work together and don't be isolated.